section number 4.4 normal distribution. So what is the name of normal distribution? Is the bell-shaped distribution. Because the shape of the normal distribution is similar to a bell. When you draw a graphic of normal distribution, the central location is the mean, mu, and the standard deviation is sigma. The PDF is given by the function 1 over square root of 2 pi sigma square e to the power minus x minus mu square over 2 sigma square. For the PDF, in the middle exam, we can ask you the question. We are given normal distribution and you find the PDF. You are given 4 function average and you find the true formula of PDF. In this function, there are 2 parameters. Mu the central location is the mean, is the median, and is the mode. Y sigma square is the variance. Sigma is standard deviation. And O square for normal distribution is standard normal distribution. Standard denoted by the variable z. So for this for normal distribution, we denote the x for the normal distribution with 2 parameters n and sigma mu and sigma square. Mean is the mu, sigma square is the variance. And we denote that follow. We pronounce x follow a normal distribution with mean mu and variance sigma square or standard deviation sigma. For standard normal distribution, we use capital letter Z when mu is 0 and sigma is 1. So when you draw the graphic, the standard normal distribution is symmetric by 0. Okay. Yeah. And sigma is 1. So the PDF, the PDF denoted by the function phi, right? Is 1 over square root of 2 pi sigma square, so 2 pi times 1 e power minus x minus 0 square, so x square is z square over 2 1 or 2 sigma square is 1. And the CDF is this area. The CDF is the function phi z as the point z. So the macro area is integral from minus infinity to z, minus infinity to z over the density px dx. Integral from minus infinity to z of 1 over square root of 2 pi e power minus x square over 2 dx. And to find the value of this table, this function, we look at the table number 3 in appendix. On the number on the table 8.1 in chapter 1, in chapter 8 in our textbook. So we upload the textbook in MST. We download the following textbook to find the value of the function phi. In fact, I have outlooked this exercise the first, the second, and the third chapter is about this part. So textbook. Our textbook is the textbook Statistics for Management and Economics.
Chật lắm thì không được vào. Tí nữa đi, trong đấy có ai ngồi đâu. Ôi, đang chật lắm không được vào.
About 19 megabyte. It's not wrong to upload this file in SD. Okay, now I open this textbook. You can go to the table number 3 in the appendix. Or you can look at the table 8.1 in the chapter number 8. This book is Statistics for Management and Economics. We go to the chapter 8. The normal distribution. Here's the normal distribution. You can see some normal with same variance but different mean, different central location, and 3 normal distribution with the same mean, the same central location but different variance square. And to find the variable of function p, you can look at the table 8.1. But I invite you to use the table in the appendix. I go to the table number 3. Okay. But in the exam, you are only given the value of the function p at the negative point. For example, here's the z, so here's the minus z, and 0 at the left hand side minus z is the phi minus z. So I want to find the phi minus z. Property of phi minus z of function phi. From the graphic, how to find phi minus z. What relationship between phi minus z and phi z? 1 minus phi z, why? Because the y area, this area, what is this area? Area at the left hand side, this point is the phi z, so the right side is 1. 1 minus phi z. And these two areas are symmetric. These two regions are symmetric, so they are the same area. So we have phi minus z equal 1 minus phi z. The property of the function. Okay. And now we study the formula to compute the standardized rule. The important rule to do this exercise. When you do exercise about normal distribution, we apply the standardized rule. Let us follow normal distribution with mu and sigma square. Then we change the variable x to z. Z equals x minus mu over sigma. Z will follow standard normal distribution with and standard normal distribution into 1. So we obtain the CDF of x is fxx. In fact, it's phi x minus mu over sigma. The relationship between CDF of x and CDF of z. So, to compute px smaller than a, px smaller than a is fxa. So we already replace that by a. We have a phi of a minus mu over sigma. And what is the pH greater than 8? To find pH greater than 8, 1. 1 minus pH smaller than 8, so 1 minus P, A minus mu over sigma. 1 minus P, A minus mu over sigma is a phi of what? 1 minus P is P minus E, so phi of mu minus A over sigma. And if you want to find PA between A and B, is FB minus FA. FB is P of B minus mu over sigma minus P of A minus mu over sigma. Okay, here the formula to use this aside about law of distribution. We apply the following example. Why last week we have corrected this example? That's all. Yes. Yeah. Have we done this aside? Yes? Not yet?
Sure.
Okay, now you find this example. And this is about normal distribution. A certain type of storage battery lasts on average 3 years with a standard deviation of 4.5 years. Which information being used for this sentence? We know the variable we observe is the lifetime of battery, right? And we know that the mean lifetime, the average lifetime of all battery is 3 years, right? And the standard deviation of lifetime of battery is 0.5 years. And the second sentence, assuming that battery life is normally distributed, so the key word in this sentence is normally. Normally or normally distributed. We apply this formula, of course, when we have the key word normal. By the probability that a given battery will last less than 2.3 years. So we want to find the probability that X longer than 2.3, is smaller than 8. So you only apply this formula. The exercise about normal distribution is very easy because we only write the formula and then we replace the parameter in the formula. We obtain the result. Okay. How to do this exercise? Last week I have explained the procedure to do this exercise. Chapter you follow how many steps? What are they? Yes, 3 steps. What are they? What's the first? First we define the random variable. What's the second? We determine or we find the PD, the probability distribution of the random variable, and then the third, you answer the question. Mình check đi, hiểu rồi. Ngồi dưới bạn ghi bài chấp tôi ghi trên bảng. Ngồi dưới là cái người vừa rồi mình nghĩ đến hôm qua là tại sao mà không bị thua. Giờ mình check tiếp cái trận đầu, sẽ check tiếp đi. Đây các bạn hồi đầu mấy cậu cô ở dưới kia chỉ ngồi chơi. Đi học chỉ đến lớp chơi vào Facebook, vào các loại tin tức xem phim. Cái gì cũng biết, kiến thức thì chẳng có cái gì. Rồi kêu hôm này có kêu khó. What first step? Okay, step 4. Step 1, we define the variable by 8 points. Let 8 be what? The right hand of the battery. The second step, because the variable we observe is the right hand of the battery. And the keyword normally. We know that they follow a normal distribution, right? Between mu and sigma square, where what is the mu? 3. And what sigma? Sigma is 0.5. Mu is the 3. And then the third step. You answer the question. Your probability that the battery not less than 2.3 years. This probability that is smaller than 2.3. Okay. So by this form, P is smaller than A is the PA minus Q over sigma. So we will feel A is 2.3, mu is 3, sigma is 0.5. Okay. Is it difficult? No. Why? Because it's only the thinking of you need A by 2.3, mu by 3, sigma by 0.5. I want to let it in. 7 divided by 5, and 7 over 5 is 1.4, so minus 1.4. Reason of calculator. How to find P minus 1.4? 1 minus 3, 1.4. Then you look at the table. 1.4 is 1.40. So you look at 1.4. And the column 0, 1.40. The probability is 0.9192. Yeah, 0.08, 08. So it's about 8.08%. Okay? What's our conclusion about this value? How to explain for farmer to understand? How to explain for farmer to understand this result? Can conclude what is conclusion? 8.08% of battery have a lifetime less than 2.3 years. Right? We explain for farmers to understand this data. We conclude that 8.08% of battery have lifetime less than 2.3%. Then question B. Yeah. Question B, you find pH between 2.5 and 3.5. Right? We use this form here. Okay. So what result? Question A. The probability that the battery will last between 2.5 and 3.5 years is the probability such that 2.5 smaller than or equal to 8 smaller than 3.5. Right? What is the probability? Phi of 3.5 minus 3 over 0.5 minus 3 over 2.5 minus 3 over 0.5. Okay. And the data phi 1 minus phi minus 1. Phi minus 1 is 1 minus phi 1. Okay, đó là gì? 2 phi 1 minus 1. What is phi 1? Open the table. Phi 1 is the phi 1.00. So we look at 0, 1.0 and the column 0 is the 0.8413. Yeah, we look at this row.
Khánh, chiều nay đi à? Nhưng mà chưa điền ship đâu. Có gì tí mày điền không? Tao để quên điện thoại.
We look at the row 1.0 and the column 0. The data 0.8413. Is the 0.6826, 68.26%. Yeah, the 68.26% of February having the lifetime between 2.5 and 3.5 years. Of course, we can use rock indicator. And when you do this exercise, you can open the textbook. When you do the final the exam, midterm of an exam, you are given the value of the function phi. Okay? You are given this value. For the normal distribution, we have also a very important property. A very important property of normal distribution is called the 3 sigma rule. So what the 3 sigma rule? The 3 sigma rule states that for any normal distribution, here mu and from what is this called? This distance is sigma. So it's mu plus sigma. Okay, and here mu minus sigma. This reason consider 68.36% from mu minus sigma to mu plus sigma. Okay, and then this point mu minus 2 sigma, yeah, mu plus 2 sigma. This distance consider 95.44%. About 99.44%. And from mu minus 3 sigma to this point mu plus 3 sigma. This distance consists nearly 99.74%. In fact, so how to conclude about 2 sigma square, 3 sigma square for this example? Nearly 100% or Really old battery with us between how many years? About 100%, or nearly 100%. Exactly 99.74% of battery mass between how many? Mu minus 3 sigma, so 3 minus 3 times 1.5 is 1.5 and 4.5. Yes. Okay. One point five is the mu minus 3 sigma. Okay. Equal 3 minus 3 times 4.5. And 4.5 is 3 plus 3 times 4.5. Okay. So we state 3 sigma rule. What is the 3 sigma rule? The 3 sigma rule states that net x polynomial division between mu and sigma square, then the probability such that x between mu plus minus sigma is 68.26%. P x between mu plus minus 2 sigma is about 95.44%. And pH between mu plus minus 3 sigma is about 100%, 99.74%. Here's the 3 sigma rule. And you can remember by the graphic. This interval contains 68%, 95%, and nearly 100%. We can prove, for example, why we prove the 3 sigma rule. The first property, what is the pH between mu plus minus sigma? Equal phi what? pH between A and B. Phi of B minus mu over sigma minus phi of A minus mu over sigma. So the lower of the greater point is mu plus sigma minus mu over sigma minus phi of mu minus sigma minus mu over sigma. Yeah. So equal phi 1 minus phi minus 1. Okay. And we have proved that this value equals 68.26%. And the second probability, what is the pH between mu plus minus 2 sigma? What pH between mu plus minus 2 sigma? You already replace, yeah? Plus minus plus 2 sigma minus 2 sigma. So phi 2 minus phi minus 2. I think the phi of mu plus 2 sigma minus mu over sigma minus phi mu minus 2 sigma minus mu over sigma. Okay. Phi 2 minus phi minus 2. What phi 2 minus phi minus 2? 2, V2 minus 1. What is V2? Okay, here on the table. 2. 0.902. So, 0.9544. 95.44%. Okay. And the last one. What is pH between mu plus minus 3 sigma is 2 V 3 minus 1. Similarly, we will replace the 2 by 3. What is P3? 0.9987. 9987 minus 1. So I is not the 44 address. 2 and 7 is the 14, 2 and 8 is the 16, and 1 is the 17, 99.74%. Okay. So the meaning of 3 sigma rule for normal distribution states that for normal distribution, about 100% of value between mu plus 3 sigma plus minus 3 sigma. But outside this interval, the density is nearly to 0, it's close to 0. Because in this interval, the total density is nearly 100%. Now we continue the next distribution. The last distribution we introduced here, we introduced about the exponential distribution. Exponential distribution. Exponential distribution. Okay, we have a break. 10 minutes, and then we continue to study exponential distribution.